Standard deviation. This video is just purely for your exam, and I will not teach you everything like a mathematician, only for what you need to know for your biology AQA exam. So standard deviation, this is the symbol, doesn't matter, you don't need to know the symbol, this is the formula, who cares, then they will never assess you with these formulas. Standard deviation is a measure of how spread numbers are. Now this statement can be misunderstood, so I want to explain that with example, and then you can understand what it means. So I have two samples, sample A and sample B. It's really important you read the data. Sample A, read it out. 8, 9, 7, 8, 8. And look at sample B. Read it out. 4, 12, 8, 3, 13. Look at the mean. The mean is very misleading. 8 is here, 8 is here. If I told you sample B and sample A have the same mean, you will never ever think that the distribution of sample B is like this and the sample A is like this. You can't tell. So you can't tell how spread the data is. You cannot from mean. Impossible. So standard deviation will actually tell you, give you an idea how spread the data is. Are the data very close together? Like A, every number is very, very close. Or is the data very, very very wide and very diverse, high range? Some people have like 1, some people have 100, some people have 1,000. Only one thing will tell you, standard deviation. So let's see how that looks like. This graph here, maybe you might not understand at this moment, but later on you will understand. If the graph is like this, okay, they don't really teach you about graphs in the exam, or that doesn't come up. But if the numbers are very, very close together, okay, the standard deviation number is small. So if you have a small standard deviation number, that means the data is very close together. That's why the graph here is very narrow. That dotted line in the middle, the green one, it shows you the average, the mean. And as you can see, everything, all the graph is very close to that line. So that means all the data is very close to the mean. If you have a data that's very, very wide and has a huge range, then the standard deviation is a larger number. So the graph here, it goes a bit more flat. As you can see, there's lots of data here far away from the mean. Lots of data far away from the mean. So anyway, even this does not come in the exam, the graph. So I'm going to tell you what really comes up. I'm going to skip this slide, come back to it later. Okay. Look at this information here. 2 standard deviation. Now this statement is really misunderstood. For now, just ignore it. Look at the data. 1, 2, 3, 2, 3, 4, 1, 4. If you were to calculate the mean of the data, the average of the data, you add them all up and you divide it by how many they are, is 2.5. But then I have plus or minus 1. So this is my standard deviation. So what does that mean? That means what I do is 2.5 plus 1, which is 3.5, 2.5 minus 1, 1.5. That means 95% of the data is between 1.5 and 3.5. Why 95? Because I am using 2 standard deviation. That can be given to you in the exam. So looking at the data here, imagine you did not see that data. Imagine that data was not available to you. And I told you that there's a data, and that's the average, 2.5, and this is the standard deviation, 1. So you know exactly now what the mean is, and you have a very good idea how spread the data is. You know that 95%, almost all the data, are between 1.5 and 3.5. So that's very, very informative to you. If I change the wording, if I told you 1 standard deviation and I left everything same, that means 68% of the data is from 1.5 to 3.5. If I left everything same, and I told you the answer here is 1 standard deviation, that means 99.7% of data is between 1.5 and 3.5. Hopefully that makes sense. Let's do one more example. 2 scientists carried out an experiment and they tried to find the rate of reaction. Scientist A and scientist B. The data shown here is in 2 standard deviation. So 25 plus or minus 5, and scientist B done the same experiment. He also got an average of 25, but plus or minus 1 standard deviation. So everything here is 2 standard deviation. Now have a pause. What does this data show? Which scientist data is more accurate? So my question to you is, which data here is more accurate? Is it A or is it B? The problem here is both of them have the same average, same mean. What I'm asking you, whose data do you think is more reliable? And the hint is looking at these numbers, plus or minus 5, plus or minus 1. If you're stuck, go back to a few seconds more to the other page I done. 2 standard deviation, what does it mean? 95% of the data. Okay, so if you have a look, scientist A, 25 plus or minus 5, that means 20 to 30. 25 minus 5 is 20, 25 plus 5 is 30. So 95% of the data, although I cannot see his data, his raw data, 95% of his raw data, the rate of reaction is from 20 to 30. It's got a range, 20 to 30. Scientist B, his 95% of data is from 24 to 26, much closer. So therefore, I want to say scientist B data is more accurate because the data are more closer to the mean, the data is less spread because there is a smaller standard deviation. Now this is the main outcome that you need to learn for your exam. Okay, that's part A of standard deviation in the exam. Let's do part B. Before we do that, few practice. Looking at this information, you should be able to understand what this is telling you. As you can see, it's a random table from exam, but without having knowledge of biology, which you don't need in these questions, just need to understand what it's telling you. Look, this is the mean length of head and body of this mouse. So 102.3, what is that? That's my mean. Plus minus 9.3. What is that? That's my standard deviation. I have to minus it and plus it, and that means 95% of the data is in that range. Everything else applies to all of them. So you should be able to extract this information now. Another one, as you can see here, plus or minus, you should know. Any number before plus or minus, any number before this is the mean. Okay. The second part of standard deviation is error bars. Trying to see which comparison between two things and trying to see is it significant or not significant. So what you do is, let's say I have a habitat A, habitat B, and habitat C. What I need to do is, in here they have given you the mean, that's the mean, 11, 8, 1. And then you have standard deviation. 3.2 here, 2.8 here, 1.3 here. What you need to do is to do an error bar. So the error bar basically is the error bar. Let's show you here. Error bar. It's the error bar here. Now the top number is the biggest biggest range. So it's gonna be your mean plus whatever the number was, standard deviation, and the bottom number is the lowest one. So that is your error bar. So this is your top one. Maybe it's not that I'm not sure if you're following, guys. So let's say this T is shown by A, although it's not relating. So 11 plus 4.2. So 11 plus 3.2 is 14.2. 11 minus 3.2 is 7.8. Okay, so that means this is 14.2 and this is 7.8. So that's how you draw the error bars. So how do you draw it? You have the mean here, then you add, and then you minus. The second thing, once you have done the error bar, sometimes they give it to you in the exam, other time they don't. You have to draw it by yourself in a rough paper. Then what you do, if the error bars are overlapping and you're comparing stuff, that means this and this, if they are overlapping, what does it mean? It means there is no significant difference. If they don't overlap, that means there is a significant difference. In here, the error bars are not overlapping. What does that mean? There is a significant difference. If they do overlap, there is no significant difference. So just to wrap it up, the second part of standard deviation is how to draw an error bar. A. B. What does it mean? If the error bars of two things are overlapping, that means the difference between them, there is a difference, but it's not significant. If they don't overlap, that means it is significant. That one more point, if you, for example, in here, are they overlapping? T and NT, they are not overlapping. The difference is significant. Why are they significant? Is because it's likely that it is not due to chance. If it's overlapping, it is not significant. Why? Because it is likely to be due to chance. In the exam, you can say error bars, or you can say standard deviation. You can refer to them as standard deviation. Both are correct.